Today we are going to be talking about the law of cosines, and before we get into that, I'm just going to put a little bit of background into why we're talking about the law of cosines and what its applications are. So let's talk about trigonometry that we've talked about up to this point. The trigonometry that we've talked about so far is trigonometry that we use when we're working with right triangles, right? That's where SOHCAHTOA comes in. It has to be a right triangle because we're involving the hypotenuse. Anytime the hypotenuse is involved, that must mean there's a side that is across from a right angle. But what about triangles that aren't right triangles? Right triangles account for some triangles, but there are so many more out there that we're unable to do any calculations with if we're just restricting ourselves to using SOHCAHTOA. So we can use trigonometry to work with any type of triangle, and there are two main laws or rules or formulas, you can say, that we'll use with any type of triangle. One of them being law of cosines, and the second one, which we'll get into next time, is law of sines. So before we get into law of cosines, there are some things in terms of just logistically, how do we label a triangle if we don't have like a hypotenuse to work with, or we can't tell what is opposite or what's adjacent if it's not the hypotenuse. So before we get into the actual formulas, here we have a triangle. You'll notice that all the angles are labeled with capital letters. Okay, angle A, angle B, and angle C, right? All capital letters. On the other hand, you'll notice that lowercase letters are used for the sides of the triangles, right? So we have the angles in a triangle, we have the sides of a triangle. Okay, so capital letters for angles, lowercase letters for sides. Now, how do you know how to go about labeling them? Does it matter how we label it? The answer is yes and no. So, in a sense, it doesn't matter which angle you label A, B, and C, but it does matter how you label it in relation to the sides. So, you'll notice in this triangle here that side A, so lowercase a, is opposite angle A. Side B is opposite angle B, and side C is opposite angle C. Okay, so in any triangle ABC with lengths A, B, and C, we can use the law of cosines, and this labeling is very important because that's how it's going to affect how we use these formulas. And these formulas only work if we use this notation for our triangles. So here it is. A squared is equal to B squared plus C squared minus 2BC cosine of A. Now in this form, this makes it very easy to find what side A is if you have side B, side C, and angle A. Now what if it were the other way around? What if you had, you were trying to find side B and you had side A, side C, and angle B? Well, then it's just a matter of either you can relabel it or you can use alternate forms of the law of cosines, where we're really just going to be rearranging the letters. So just note that these two, they're really the same equation as the first one. It just really depends on how you've labeled your triangle and what you're looking for. So B squared equals A squared plus C squared minus 2AC cosine of B. C squared equals A squared plus B squared minus 2AB cosine of C. Now, what if instead of the measures of the sides, you were trying to figure out the measure of the angles? There's an alternate form, which really is just the same equation, but getting that cosine of the angle measure. So for example, in the first one, if we were to subtract B squared, subtract C squared, and then divide everything by negative 2BC, that would give us cosine of A by itself. And so this alternate form, which you'll write down in the next box, it just makes it a little easier to find the measure of the angle because you already have the angle almost completely by itself on one side. So cosine of A is equal to B squared plus C squared minus A squared all over 2BC. And then similar to the last box where you wrote down 3 different forms based on what you might be looking for. So say instead you were looking for angle B. Well, then it's just a matter of switching around the sides a little bit. So cosine of B is equal to A squared plus C squared minus B squared all over 2AC. And cosine of C is equal to A squared plus B squared minus C squared all over 2AB. Okay, so let's go ahead and see how we can actually use these to find measures within a triangle that's not a right triangle. So here's example 1. We're solving a triangle using law of cosines, given a side, an included angle, and a side. Okay, so solve triangle ABC shown below. Now if it helps you, feel free to label what you have. So angle A, B, and C are already labeled. Side C is labeled already. And let's see, 16 would be side A, lowercase a. 10 is across from angle B, so that would be lowercase b. Now you're asked to solve the triangle, so just like solving a right triangle means you find the measure of all the sides and all the angles. So we're going to do the same thing here. So that means we need to find what the measure of side C is. We need to find the measure of angle A and the measure of angle B. So let's start with side C. So if we're trying to find side C, we'll use C squared equals A squared plus B squared minus 2AB cosine of C. And we'll fill in everything we know. We know A is 16, B is 10, angle C is 110 degrees. And then go ahead and simplify everything on the right-hand side as much as you can. Be sure that you do take 16 squared plus 10 squared. Okay, so that's 256 plus 100, that's 356. And then you have 2 times 16 times 10, which is 320 times cosine of 110. Now, you can absolutely put the entire thing into the calculator, that's fine. Some people prefer to do it one step at a time, that's fine too. If you do it this way, where you're taking it one step at a time, please make sure that you actually multiply 320 times cosine of 110 first, before you subtract it from 356. There seems to be, a common error where you see 356 minus 320, you want to subtract that first before you multiply by cosine of 110, but 356 minus 320 is not in parentheses, and your rules of PEMDAS still apply here, so you want to multiply first before you subtract. Alternatively, if you're unsure or it's just a lot to keep track of, you can just put the entire thing into the calculator, 356 minus 320 cosine of 110. Your calculator follows rules of PEMDAS. And then just make sure that you take the square root because you're trying to find what C is, not what C squared is. So take the square root of that. It should come out to be about 21.6. Okay, so we found the measure of one side. Now we still need to find the measure of angle A and angle B. Now since we have angle C, once we find the measure of angle A, we can just subtract angles A and C from 180 to get angle B. But we still need to find angle A. Okay, now that we're trying to find the measure of an angle, we want to use one of those alternate forms, the second box that you filled in. So cosine of A is equal to B squared plus C squared minus A squared all over 2BC. Across from angle B is 10, so that's 10 squared plus C squared. Well, what's C? We just found C, 21.6 squared, minus A squared. What's A? 16. So we have 10 squared plus 21.6 squared minus 16 squared all over 2 times 10 times 21.6. Now note that this is going to be an approximate answer. The reason why I've put the approximation here already is because 21.6 is already rounded. Okay, so once we put 21.6 in there, it's already an approximation because it's not exactly 21.6, right? We've done a little bit of rounding there already, so it's still going to be a good approximation. But just so you know, that's why we have that there. Now, what you want to do here is, again, you want to make sure if you are putting this into the calculator does follow rules of PEMDAS. However, in order to make sure the calculator knows that the entire 10 squared plus 21.6 squared minus 16 squared is all in the numerator, you'll need to put that in parentheses. Okay, so if you want to put this entire thing into the calculator, that's fine. Put the numerator in parentheses before you divide. The reason is because if you don't, it will follow rules of PEMDAS and it'll look like 10 squared plus 21.6 squared minus 16 squared divided by 2 times 10 times 21.6. It'll look like it should do 16 squared divided by 2 and not the entire thing in the numerator divided by 2. So my best advice is to put the entire numerator in parentheses, then put divide, and then put the entire denominator in parentheses. If you want to do it separately, that's fine. Just get the numerator, write that number down, divided by the denominator, put that number down, and then divide the two numbers. That's fine as well. This should come out to be about 0.7172. Now, we still haven't found angle A yet. We found what cosine of A is approximately. So anytime you're trying to find the measure of an angle, just like when you were solving right triangles, you want to use the inverse trig function, in this case, inverse cosine. So inverse cosine of 0.7172 comes out to be about 44.2 degrees. Okay, so we found one side, one angle. We still have one more angle left to find, but the last angle is pretty easy to find because we have two angles already, and we know the triangle sum theorem applies to all triangles, not just right triangles. So 180 minus the 110 minus the 44.2 comes out to be 25.8. So angle B is about 25.8 degrees. Okay, let's do another example, slightly different. In example 1, we were given two sides and the included angle. In example 2, we are going to be given three sides. We're not given any of the angle measures. Okay, since you already know we need to find all three angles, that should be a big clue as to which formula or which form of law of cosines we want to use. So remember, the first form of law of cosines is easiest to find the measure of any sides, but the second form, the alternate form, makes it easier to find the measure of the angles. So we can start by finding the measure of angle A. You might want to label all your sides. So across from angle A is 20, so that's lowercase a. Across from angle B is 15, so that's lowercase b. Across from angle C is 8.3, so that's lowercase c. So this is 15 squared plus 8.3 squared minus 20 squared all over 2 times 15 times 8.3. Okay. Again, just like in the last example, make sure you put the numerator all in parentheses, divided by the denominator all in parentheses. If you want to do it separately, find the numerator, write that down. Find the denominator, write that down. That's fine too. Cosine of A should come out to be about negative 0.4261. Use the inverse cosine to find angle A, and that comes out to be about 115.2 degrees. Okay, so that's one angle measure. Let's find another angle measure. Let's say we'll find angle B. So cosine B is equal to a squared plus c squared minus b squared all over 2ac, so that's 20 squared plus 8.3 squared minus 15 squared all over 2 times 20 times 8.3. Again, put the numerator all in parentheses, put the denominator all in parentheses, divide, and we get cosine of B is equal to about 0.7346. Use inverse cosine to find the measure of angle B. That comes out to be about 42.7 degrees. All right, we have two angles. To find the third angle, use the triangle sum theorem so that you don't have to do as much work. So 180 minus the 115.2 minus the 42.7 comes out to be 22.1 degrees. All right, our last example is a word problem. It says 2 trains leave a station on different tracks. The tracks make an angle of 125 degrees with the station as the vertex. The first train travels at an average speed of 100 kilometers per hour, and the second train travels at an average speed of 65 kilometers per hour. How far apart are the trains after 2 hours? Okay, so first of all, you have a diagram here. But think about where did this 130 and where did this 200 come from? I don't see those numbers anywhere in the word problem. The 125 degrees we saw, it says the tracks make an angle of 125 degrees with the station as the vertex. Okay. Now, there are some other pieces of information given. It says the first train travels at an average speed of 100 kilometers per hour. That's the speed. Now we need to know the actual distance because we want to know how far apart the trains are after 2 hours. Well, if the first train is going at a speed of 100 kilometers per hour for 2 hours, well, how far has that train traveled? After 2 hours, 200 kilometers, right? Just multiply rate times time gives you the distance. Same thing with the second train. It travels at an average speed of 65 kilometers per hour, so after 2 hours, rate times time, 65 times 2, is equal to 130. So that's where the 200 and the 130 come from. Now, in this word problem, because you're just asked for how far apart the trains are after 2 hours, you actually don't need to find what the measure of angle A is, what the measure of angle B is, right? Whereas in the last 2 examples, you were asked to solve the triangle, so you have to find everything. Here, you just want to know what side C is equal to. Okay, so if we're just trying to find side C, we'll use C squared equals A squared plus B squared minus 2AB cosine of C. We'll plug in for A. So A is the one that's across from angle A, so that's 130, so 130 squared, plus B is across from angle B, so that's 200, so 200 squared, minus 2 times 130 times 200 times cosine 125 degrees. Again, if you want to, you can plug that entire thing into the calculator. The calculator will follow rules of PEMDAS. Alternatively, if you do it one at a time, 130 squared plus 200 squared, you end up with 56,900 minus 52,000 times cosine of 125. Make sure you multiply 52,000 times cosine 125 first before you subtract from 56,900. Or you can plug the whole thing into the calculator again. It will follow rules of PEMDAS. So take the square root of both sides because we want C, not C squared. And C will come out to be about 294.5. So after 2 hours, the trains are about 294.5 kilometers apart.